guys, today we're going to solve this question, shortest subarray with sum at least k. So it is given that it's a hard problem, but I'm gonna give you a simple example to solve this question. So what does this question say? So let us assume that I'm gonna take a simple test case for you guys only, since you are my bros. So let's say I have this array 1, 2, and 1, and I have a value, let's assume it is 2. So we need to find a subarray whose sum is at least k, which means that it could be greater than k or equal to k. These are the two possibilities. So let's say this is the array. I mean, it is pretty obvious that if I try to pick this subarray whose length is only 1, and it also satisfies that it is at least k. So yes, it is, since it is 2. I mean, there is another array which is 1 and 2, and their sum is 3, which is also satisfy the condition. But the thing is, the question wants us to get the array which is the shortest. So that's why our answer is this. So how can we do this? I mean, there is a pretty simple way. And also one more thing. A question also tells us that if you're unable to find any subarray, just return -1. So we're gonna handle that case. It's obvious. So if the array which we have given have only positive numbers, then it would be a pretty easy question since we just need a left pointer and a right pointer. And what we can do is we're gonna move this right pointer right at this way. So we're gonna maintain our current sum window just like a sliding window, which is currently we have sum of 1. Then after that, when I try to move our right pointer right over here, then my sum becomes 3. So as it becomes 3, what I can observe is it satisfies this condition that it is at least k. So this length which is 2, this could be our possible result. It's gonna be 2. But there is one more catch. Since we have found that the maximum size of the subarray whose sum is at least k, so we know that if I try to move my left pointer, it's gonna shrink the value. I mean, it's obvious, man. I mean, if I shrink this value, obviously I'm gonna subtract, reduce it by 1, so the sum becomes 2. And also, this also satisfies the condition, and also this also give me the minimum subarray length, which is 1. So it's a pretty good question. But why can't we use this? Because in this question, I mean, it is pretty much given that the array which we are given can have negative values, as you can see this example. So it's gonna pretty much fuck up the situation. So let's see, I mean, how it's gonna mess up the thing. So let's just, I mean, bro, why am I removing this much, bro? I mean, yeah, just okay, just remove, bro. Okay, cool. So basically, what does it tells, man? I mean, basically, if I try to put -1 over here, I mean, we still know that the if the value of k is 2, our answer is obviously going to be this array. But if I try to do the same logic over here, let's say r over here, l over here, and r over here, current sum is basically -1. But once I try to move my r, the current sum basically becomes 1. So this number is not at least case. So it doesn't make sense if I try to move my left pointer. Although I know that this is the answer which we are looking for, but we know that if I try to move my left pointer, it's gonna reduce the value. If it's gonna reduce the value. If I just make sense. I mean, if you know that, if I try to, bro, basically it means that, bro, is gonna reduce the value. It's gonna reduce the value less than 1. So that's why we can't move our left pointer. So in another contradiction, we're gonna move the right pointer and do the same thing. So that's why here's a catch. In the negative number, it just doesn't work. So how can we solve this question? So pretty much there is a way. I mean, it's kind of hard to find, but there is a way. We gonna use min heap. So what does min heap gonna help us with? So let's just see. I mean, it's a pretty straightforward, bro. I mean, you don't need to think that much. So I'm just gonna run through the algorithm and gonna show how this magic works. So and also you will get to know why. So let me just draw the min heap for you guys. So let's just consider that this is min heap, and I'm just gonna call it short form mh. I mean, guys, I really don't want to write. Just want to write. Don't want to write this much, bro. Yeah. So in this min heap, we're gonna store two values. The first value is gonna be prefix sum, and the next value is gonna be the last index, which is called as lid. Now it's right now don't gonna make much sense, but after I run the algorithm, you will get to know why it is working. So right now I'm going to use a right pointer. I'm also going to maintain this current sum all the time. And also I'm going to pick a response, which is a result. So basically for right now, it is infinity since we want to find the minimum value. So what can we do, guys? We are at right this portion. I mean, at this part of the array. So what we can see that the current sum is -1. Cool. So we can also store that thing into our heap. So the prefix value, the prefix sum is going to be -1, and the last index is pretty much the value of r. So which is nothing but 0. So I mean, just guys, understand, bro? Yeah. So this thing is 0. Yeah. Then after that, we're gonna iterate this thing to right over here. Now r is this. Since we have just filled the heap, we also going to check this thing, bro. I mean, I've just increased this r. So what does it mean? The current sum is also increased. If I try to add plus to it, then it's gonna become 1. So I'm gonna store the prefix 1 right over here, and the value of r is basically the 1. So now, guys, I mean, why we are using heap? So I'm gonna tell you right now. So as we know that our current value is 1, right? it doesn't satisfy the condition. But since our heap is filled, we can just pop out the minimum value. Since heap work in a way that this initial value is, the heap will arrange the value according to the initial value which is given. So it is -1, so it's gonna pop out first. So it's simply going to pop this thing out. Before popping out, we're gonna look that either if we try to subtract this value, which is -1 to it, so does it satisfy the condition? Yes, guys, hell yeah. So basically, it is at least k. So as you can see that it satisfies the condition. So what does it mean? It basically means that we might be able to find our answer. So here is the catch. This is the value current index of r is basically 1, and the last index which we have popped out from the heap is 0. So our result, possible answer of our result could be 1. It's still not sure, but we also know that the minimum value is 1 if I try to find subarray, since it is the minimum what does the 0 even means? So yeah, so that's how the algorithm works. So once after that, we're gonna move our right pointer again. Now in this way, we know that if I try to move this thing, our current value, since the current value was 1, and if I try to this sum it up, and it's gonna become 2, and the last index is going to be 2, and so on, bro. But since we already know that we have found our answer, which is going to be 1, so we don't even need to iterate that much. So let's guys just code this thing up. So yeah, tell you the visual explanation of this question. So basically, I'm gonna just zoom this code panel just for you guys, and I'm gonna code it up. So what do we need? So basically, we need to iterate over the array by using the right pointer. So I'm gonna say like this, and so this will iterate all over the pointer. So for that, we need a result. So our result is gonna be float, since it's gonna be float of infinity, so that we can capture the minimum values. You know the obvious reason. And also, if we are unable to find the minimum value, which means that if the result is equal to the float, which means that we were unable to find anything. So if that's the case, we're gonna return -1, since that quotient wants. As we have found some array whose minimum length is at least k, so we're gonna return the value of rest. So for that, first of all, we also need to keep track of the current sum. So I'm gonna say cs is 0. So every time we iterate over, we know that if I try to sum it up, it's gonna give us the current sum value. Now it is possible that the current sum is at least k. If that's the case, then you're lucky, guys. What we're gonna do is we're gonna just find out the minimum of the result which we have, and the r plus 1. So you must be thinking why it is r plus 1. So guys, just think, man. Let's say I have this array 1 comma 2, 1 comma pro, just whatever. Just look at the index 0 and 1. What if my index, my r was at this point? What if my r was here? So does my result gonna be 0? Hell no, bro. Array, the answer cannot be 0, bro. There is no array, which means basically no array exists. So that's why I'm doing r plus 1, so that I can get the value of length 1, although it is at 0 index. Yep, and so on. Yep, that's all. That is why I put in plus 1. So after that, what I'm gonna do is I'm gonna check in my min heap. Although I haven't added anything, but if I try to move more on iteration, then it's gonna be inside this heap. So oh my god, I forgot to initialize that there is a min heap which exists. So right now just an empty array. And also what I'm gonna do is I'm gonna check that, and if my current sum which I have, if I try to subtract the value of min heap, so min heap and this. So what I've told you guys that in my min heap I'm gonna store this. What I'm gonna store prefix value and the last index. Okay guys, so right over here what we can see is if I try to subtract this thing, and by min heap prefix value which we have 0th for the minimum value which is on the top, and if I try to do this, and if it satisfy the condition which the quotient want, then what we're gonna do is, oh where did I even type in, bro? What the hell, bro? So just copy this thing up and just paste it right over here. So I was here at this line. So yeah, basically then after that what I'm gonna do is I'm just gonna pop out the value. How I'm gonna do it? So basically in Python we have already a structure called heap queue, and if I try to do heap pop and just put the value of array inside it, they're gonna treat the array as in heap. So and it's gonna satisfy the condition. Then what I'm gonna do, I'm just gonna pick out the prefix value and the last index, which is I'm just gonna call it LID. It's gonna sound kind of cool. So then after that what I'm gonna do? So basically then after that I'm gonna update the value of result, since we have found out there is a possibility that this could be our answer. So result, then the current index we are currently at, and LID. You must be thinking why shouldn't we add plus 1? So the thing is, once we are in prefix, we actually want to exclude the value. So let's say we have this array. So r, basically r is at this place. Let's say here, and the current LID is over here. So we actually don't want this thing to be included. So that's why even if I do the difference of this, only this will be included and this will be excluded, and that's what the question want from us. Then after that what we need to do, yeah, it's obvious, man. I just need to do a heap pop, heap push. So I'm gonna use this same class function of heap push, and I'm gonna tell that treat this thing array as heap and store the value of two things. The prefix, what is the prefix? The current sum itself. And what is the last index? It is the r. And if I try to run this guy, I hope that it hopefully run. I mean, if not, just I mean, I don't know. I'm really don't know. I just hope that it will work. So I pretty much uh, fucked. I mean, yeah, I don't want to say that word. Just leave it, bro. What's the problem? Heap q is not defined. Okay, okay. So it is basically heap q not. I mean, it's just a typo, guys. Yeah. I hope that it will work. Okay, so it is not working. So what could be the cause? Okay, guys. So I just for missed out with one small thing. So I actually not going to add the index. I'm gonna add the value of that index. So it might work right now. I just hope, man. I even don't know. Yeah, so finally we were able to solve this hard question. I hope it passes all the test cases. And yeah, hopefully we are able to do this question. Yeah, thank you guys.